Cool. So nice to meet you, everyone. I'm very happy to be here. I know some of you, so it's always a pleasure to see familiar faces. And to the other one, I'm Paul. I'm the founder of Kosmik, which is a spatial canvas with some, I think, Alto and Kosmik share some kind of family tree. We're both exploring what can be done with spatial interfaces. And so I'd say that my passion for computers come from computing history. So the very short story is that when I started in computing because I wanted a computer when I was very young, and my parents were like, no. And my uncle gave me a very old Atari computer from 1983. And that computer booted in BASIC when you plugged it into a TV. So it could only do one thing, which was to show a blinker and to tell you, like, program me in BASIC. And I found that absolutely fascinating because it was a computer that was not like telling you open an app to do something or put a program to do something. It was a blank canvas to explore. And so today what I want to do is, I'm not going to talk about Kosmik, but I'm going to try to talk about the roots of computers and what I think could be done to make computers more suited for groups. And so for me, the main problem that we have right now is that the modern computer is turned inwards. And what I mean by that is that, and I'm not talking about local first, but basically the computers we have right now are all descendants from computers from the 1970s and 1980s. And so basically what happens is that, for example, let's say I have those pictures. They're stored somewhere. They may be on my desktop, which is basically the only physical space on my computer. So it's probably extremely cluttered because it's the only place, actually, where I can put stuff everywhere, where I can organize myself. And this is also one of the only space on my computer that I cannot share with anyone. This is strictly private, which is good and bad. And so if I want to share those three pictures, I have to go through one of those services. I have to find a solution, so I'm going to remove them from their context. They may have an awful title name. They may be very, it's very hard to share context with someone, and I think like Andres' talk exemplified what can be done if you have computers that are much more fluid and much more physical. And so basically what we end up with right now is a pile of abstraction. So you have your desktop, which is a place, which is very personal, and everything that is related to groups on computers right now resides at another level, is abstracted away. If you want to share something, you have to use a service. You have to open your browser. And when you do open that browser, you're going to open yet another app, another service to share those files. And that's, I think, like basically what happened. I don't know if you can see that, but I think like the culprit is in what happened to microcomputing. We started with very simple computers that were basically program players, like you were putting a floppy, you had a system, the disk system, the system disk would contain the applications, and you would have like maybe 2 folders with files inside them. And what that means is that the hierarchical file system was mildly effective, like it was not the burden that we all know on our hard disk right now. And then we started to add other media like disks that were much bigger in terms of how many files they could store, and then cloud services and email, and all of that was cobbled together, but we never went to the root of the issue, and we never tried to rethink what were the paradigms that would be needed for a group-first computing experience. And so what I want to do is ask you to open your computing history books to the 1945 page, which is, as you know, the year where Vannevar Bush wrote a very known, very well-known, very important article called As We May Think, that was published in July of 1945. And I think this is a very interesting, like very humane reaction. So Vannevar Bush, you may have seen him in the Oppenheimer movie, because at some point he testifies for Oppenheimer about like the probability of the character. And Vannevar Bush was the scientific advisor that oversaw the Manhattan Project. And at some point he was frightened by the idea that humans now had at their disposal tools that could destroy the whole humanity. And he thought that were the apocalypse to happen, we would need a system to not start from scratch, which is something that if you've read like Foundation from Asimov, we can recognize that kind of atomic scare during all the 50s and 60s, like basically, what do we do if everything gets destroyed, and how do we like shorten the time it will take us to restart civilization from 10,000 years to 1,000 years? And Vannevar Bush was concerned with something else. In the article, he talks about Mendel's theory, which I think is about like the genome, and he's like, Mendel's theory was published in the late 19th century, but was not really well known until 30, 40 years later, because the publication was not put in the hands of the right people. So he thinks that we have several problems. An index, how do we index stuff? How do we record stuff? And how do we resurface stuff? And so I want to quote the beginning of the article, which is, there is a growing mountain of research, but there is increased evidence that we are being bogged down today as specialization extends. The investigator is staggered by the findings and conclusions of thousands of other workers, conclusions which he cannot find time to grasp, much less to remember as they appear. Yet specialization becomes increasingly necessary for progress, and the effort to bridge the gap between disciplines is correspondingly superficial. So basically, Vannevar Bush thinks that the MEMEX, which is the desk that I showed you in the beginning, which was a desk which would contain microfilms that you could project, that you could link together, where you could add annotations to create what he called trail, could help to bridge the gap between disciplines and help us resurface informations that otherwise would not have been found. So in 1945, we have As We May Think. And then we have all of those, like, all the great researchers that are beginning to think about those problems. And the second researcher to think about those problems is Joseph Carl Robnett Licklider, which is well known because he worked at the IPTO, at the MIT, and then afterwards at the ARPA. And Licklider was originally a scientist, and he was himself concerned about the amount of time that scientists were losing producing stuff that were not really important. For example, he talks about how some scientists are trying to come up with a model of the human ear, like how do we hear, how does that function? And to do that, we need to do plotting, we need data, we need to have graph, and then we need to interpret them. And so Licklider at some point just recorded all of his activities, and he found out that 85% of the time he was spending on what he called non-scientific activities was 85%. So basically 15% of his time was spent really generating ideas that were pushing his field forward. So he wrote an article in 1958 called Man-Computer Symbiosis, which is about how he thinks that machines could help us think better and not only think more, but think more acutely. And this is completely another topic, but I think that right now the problem is that we are yet again working on tools mainly that are very good at generating LLMs, but not super good right now yet at resurfacing, storing, and helping us really like crossing, like, bridging the gaps between discipline and collaborating more effectively as a species. And then in 1962, Douglas Engelbart, super well known, don't tell me he invented the mouse. The mouse was a byproduct of a much larger project called the NLS, the online system, which was a fully collaborative first computer that he demoed in 1968 at the Mother of All Demos, which you may have seen on YouTube. And if you haven't, please go on YouTube, type Mother of All Demos, and just look at Douglas Engelbart making video calls, sending emails, and editing a Google Doc, basically, with people in 1968. And so those three articles, those three seminal papers, to me could be interpreted as such: storing and resurfacing, interacting and generating, and collaborating. And it looks like we've the first two, and quite well. But the third one is, in my opinion, not yet here. And so we're going to try and see how. So another quote from Douglas Engelbart that he wrote much, much later in an article in 1995 after the web started to be more democratized is the key thing about all the world's big problems is that they have to be dealt with collectively. If we don't get collectively smarter, we're doomed. And so what is really funny, if you look at the context of when those articles were published, Man-Computer Symbiosis, Augmenting Human Intellect, a Conceptual Framework, and what happened in that decade that spanned from 1962 to 1972, which is the year where Alan Kay published the Dyna book, A Computer for Children of All Ages, it looks like those problems were starting to appear in other areas of society. Like Robert Probst, one of the best industrial designers of the 60s and 70s, who designed the Action Office for Herman Miller, said this thing: today's office is a wasteland. It saps vitality, blocks talent, frustrates accomplishment. It is the daily scene of unfulfilled intentions and failed effort. So there were concerns everywhere about, like, we generate a lot of knowledge. Robert Probst is even quoted as calling the 60s the decade of the paper apocalypse. So we generate too much, we don't have good system to index, we don't have good system to collaborate, we don't have good system to share. And so this is an image I love. this is a living structure by Ken Isaacs, who is a designer. And he says, as the imagination of many men creates a fantastic new world, the danger is that the individual man may soon find himself lost in it. So everywhere, architecture, design, workplace, computing, everybody was concerned about how are we going to deal with the fact that now we have tools that allow us to generate more and more, that basically we have to do more paperwork, but that we do not have machines that would allow us to deal with that. And so Ken Isaac's answer is to basically find a way to give people the means to build their own tools and to work at a smaller scale in smaller network, which I think resonates with the people in front of me. I'm not sure you are fans of big centralized platforms that run on distant cloud servers. So not too hard for me right now. But what I think is super interesting is that he went kind of overboard, and that's Ken Isaacs, in front of what he called the media box. And he was like, education needs to be rethinked from the ground up. Like, we need to invent a space that would allow us to compute and to understand how media would work. Like, we need a spatial box with projectors and images everywhere. Like, we need to find a way to work with density. We need to find a way to have dense ecosystem, dense tools to work as teams. And so, again, the quote from Engelbart, the key thing about all of the world big problems is that they have to be dealt with collectively. If we don't get collectively smarter, we are doomed. So what happened? Because basically, if you look at the Xerox PARC work, if you look at augmenting human intellect, if you look at all of those papers, it's very clear that there is an understanding that the computer is by default a multiplayer experience. And I think that can be explained by the fact that they were all working on time-sharing system, where basically there's never only one user. The microcomputer, the personal computer, was not yet here. The problem is that in the 60s, basically, and the 70s, we witnessed the apparition of the microprocessor, and so it became possible to build for less than $1,000 a box that would be a computer. And so all of those ideals, like the ones from Ken Isaac, from the whole hard catalog, like that idea that you should build your own stuff, that idea that you should be in control of your tools, got translated as is to the computing world, and basically people started to build their own computers and to experiment. But those computers were, how could I say that, the equivalent of homesteading. Like, you have a computer, it floats on a desk, and you have to do everything yourself. You have to do your programs, you have to handle your files yourself. There was no real concept of what could be an operating system. And long story short, I think that the evolution tree forked at that point, and there was basically the researchers at the Xerox PARC and in all of those institutions working in a network-first, collaborative environment, thinking about new technologies to collaborate better, and the hackers working on computers for individuals. And so this is Alan Kay with the Dynabook, which, as you know, was kind of the, I'd say, the North Star of what happened at the PARC. If you look at the PARC most well-known work, which is Smalltalk, basically everything the PARC did, Alan Kay called that an interim Dynabook. We cannot have liquid crystal display to put in a tablet. We're going to have bitmap display. We cannot have yet cordless networks. We're going to have Ethernet, and on and on and on. So basically, they built a world that would simulate what could be done later on once technology catch up. And those images are about the same year. And so here you have big display, high resolution, multiplayer, connected through Ethernet, laser printer, and I'm going to show you an image later on. Smalltalk was what I would call a default multiplayer environment that was really fun. Like, for example, let's say you were working with 4 people. On the desk of your Smalltalk computer, you would have an outbox and an inbox with the name of those persons. So you were not going to a mail app. If you wanted to share something with them, you could just duplicate a text file and drop it in the outbox of Mark, for example, and it would be sent to Mark and appear on his inbox, on his desk. And so there was no abstraction, there was no intermediate layer. The computer itself was thought as a device for groups, which the Apple II was not, because it's much too expensive. And so what we know in computing history as the Trinity, which is basically between 1976 and 77, the introduction of the Apple II, the TRS-80 from Tandy, and then the Commodore PET, which were all introduced in a very, very short time span. All of those computers do not even have a concept of what can be a network. They will have later on, but basically in their first incarnation, the idea is that man on the street wants to learn how to program, wants to play games, wants to do accounting, wants to even like have a digital store of his kitchen recipes, cooking recipes, and that's what we're giving with those computers. And so computing became personal computing, and the motto of brands like Atari, Apple, Commodore, all of those brands from the 80s was one desk, one computer. And there's a quote from Steve Jobs, because when Apple went to the PARC and they were introduced to the graphical user interface and to the other technologies, he said the following thing. I went over there and they were very kind, and they showed me what they were working on, and they showed me really three things, but I was so blinded by the first one that I did not even really see the other two, which I think is like Steve Jobs is the only one that basically admitted that he missed two critical innovations that he would work on later on. So what did he saw? He saw the graphical user interface, and the Macintosh was basically redesigned from the ground up to have a graphical user interface. Point, click, copy and paste, all of those things that we know were forked from the PARC, brought into Apple, but a few key concepts from Smalltalk were omitted for cost reasons. And if you know about the Xerox Star, which is a computer from 1981, it was introduced on the market for $10K, which would roughly translate now to, I think, $30,000. And the Mac was introduced for $2,495, which was already super expensive, but much less so. And so what did he miss? So he saw the GUI, and he missed networking and object-oriented programming. And I think you cannot fault someone going to the PARC in 1978, being so enamored with the idea of personal computers, that he saw that one thing that can make the computer usable by the whole planet, and he has one idea. Take the price down, make it available to everyone, and sell it. And so in Europe, for example, here, it's very interesting because there's not a brand of computer in Europe that tried to basically make a computer that would be more powerful than in the US, except Acorn, which is at the origin of the ARM chip. And so the idea was to do computers that would be super small, super inexpensive, and that you could buy everywhere to learn to program and to basically have your own thing. And there was one goal in the computing industry, which was to have a computer with 128 kilobytes of RAM, which would be massive, and to sell a kilobyte of RAM for less than $1. And that's what Atari did. And so that frame of mind got people, I'd say, people got blindsided by everything that was happening in the computing industry. And so Bill Atkinson, for example, creator of HyperCard, which is I'd say the first real authoring system for a personal computer, said the following thing. I have realized over time that I missed the mark with HyperCard. I grew up in a box-centric culture at Apple. If I'd grown up in a network-centric culture like Sun, HyperCard might have been the first web browser. So basically, the whole computing industry forgot about making sure that you could collaborate because it was super expensive. So basically, if you remember the 3 seminal articles, the computer industry in its first 10 years of existence succeeded like wonderfully at store and resurface, interact and generate, but collaboration was nowhere to be seen, except on very big, expensive computers that you would find nowhere except in very, I'd say, very big companies. And so Apple tried to kind of backtrack. They introduced the Macintosh Office, which is a local network. And this is where I would say we ended up in what I would call the suburban computing territory. So basically, first microcomputer, homesteading, you're in your own little farm on the hill, doing your own stuff, having fun. And let's say the Xerox PARC would try to build super affordable homes, super dense, like buildings in the city. And now we're stuck in suburban trinity of computing. Proprietary file formats, apps, and services. And basically, those are the 3 abstraction layers that I think block what could be a real group-first computing platform. Like proprietary file format means that you have to make sure that the recipient has the app in which you created the original file. So what do you do to make sure that it's going to work? You export it as a PDF, so you lose all the interaction. Or you have to share it through a service like Figma or Google Doc, but then you didn't account, and you are kind of trapped in a centralized infrastructure. So basically, this is where we're stuck. But there was one solution. When Steve Jobs understood that he had missed the mark, he started Next, which was bought by Apple, as you all know. And there's one thing that is not super well known about Next. It was not only just a very fancy Unix computer. Steve Jobs tried to introduced the world to what he called the wonder of the 1990s, interpersonal computing. So basically, that idea that now we could work on computers and have organization exist solely in the electronic realm, and that would be revolutionary. And so there is a very lengthy quote, but I think it's important to read it completely. We can change an electronic organization like that, and what's starting to happen is that as we start to link these computers together with sophisticated network and great user interfaces, we're starting to be able to create clusters of people working on a common task, literally in 15 minutes worth of setup. And these 15 people can work together extremely efficiently, no matter where they are geographically, and no matter who they work for hierarchically. And these organizations can live for as long as they're needed and then vanish. And we're finding that we can reorganize our companies electronically very rapidly, and that's the only type of organization that can begin to keep pace with the changing business condition. So interpersonal computing is that idea that we need to have an operating system and even hardware that is multiplayer first. But Next computers were not that revolutionary in that respect. They were doing wonderful things, but they were still operating with a classical GUI, with a hierarchical file system. And so what should have been, which is basically, I have a computer, and I want to share the whole state of that machine with you, got basically blocked by, we need another computer in between to do that, and you have to pay to use it. And it's in a distant location. You will never know where it is. By the way, I'm not coming up with any solution in that talk. I'm just trying to have the lay of the land, so feel free to interrupt if you have ideas. I'm all ears, because basically this is what we're living in right now, and I think this is a very sad state of things, a very sad world. This is suburban computing at its finest. I'm sharing my screen, but we cannot really interact. I see you, but I cannot really interact with you beyond you hear my voice. So basically we have a very, very, very low bandwidth, even with we have wonderful machines right now. But this is what we do, right? Like Josh definitely does not want to be here, so he's muted. Dayami has a fake background with a brick wall because she does not want us to see her kitchen that is not cleaned up. So we are in a very, very sad state of things where basically we try to cobble up together stuff and we pile abstraction on abstraction on abstraction, and we are living in that absolutely mad world where you boot up your computer, you open 30 apps, 20 of which are Electron wrappers, which gobbles up 4 gigabytes of RAM each. By the way, Kosmik is like that too. That's like awful because we cannot fund a new computer. And so the problem is that then you arrive on your computer, you have all of those files, you have work to get done. Some people speak with you by email, other by WhatsApp, other by Slack. You have files to send them, you send them everywhere. You duplicate, you triplicate them, you use massive amounts of storage, and that's awful. But big companies have a solution for that. The metaverse. So basically this is the same thing, but now we don't have legs and we have less emotion, but I think this is the same person. Like this is Josh, and Josh definitely is much more happy. And what I think is crazy, I think it demonstrates that we have a hard time thinking about what could be, is that they have computers in the computer that they were on their heads. Like they're sharing the screen of the computer within the computer. And I think we can do better, as you've seen in Andre's talk. So basically, where are we? What should we do? What can be done? Are we doomed? I don't think so. We need to reinvent tools. We need to try and have, to go back to your question about socio-economical factors, this is not a computing problem as it is a people, education, money problem. We need to find a way to have very low-cost computers that are sold with their whole documentation, where the hardware is open. And I know this is kind of wishful thinking, but some companies are already doing it, like the Raspberry Pi is an outstanding success that builds up on those ideals from the very early microcomputers. And we need to find a way to start fresh. And maybe it will be through a web service, maybe it will be through something much more ambitious and difficult to build. But this was very interesting. What I think is very fun with the original Macintosh is that basically they looked at that screen, right? And they said, this is the future, we're going to do the same. But if you look here, there are so many things that we do not have right now, like those famous outbox and inbox for Williams, for example, the printer icon on which you just take the document, drop it, and boom, it's get out of the printer. All of those servers that are accessible right here, those folders that are shared on the desk itself, we never do that anymore. Apple Talk, Local Talk could do that. We never do that anymore, really. We go through a Dropbox, we go through a Google Drive. There's always another abstraction layer. I really think this is the problem. And so hopefully, some people, and this is what I want to hand the talk on, thankfully there are some people that are making amazing explorations to make computers nicer and collaborative by default. Like Matt Webb, for example, who built that awesome stuff where when you go on his website, you can see other people cursors and they can talk together. And so basically, I think this is really what we need. Any layer on the computer should be a playground for all of the users. That's probably doable with everything we have right now, right? And we have Omar and Andres building folk and like showing what is possible if you try to go back to a more democratic medium, which is paper, and have a low-cost computer that you can interact with on any surface, which is like crazy if you think about it. That's great. And we have people like Aslan Elza. Aslan created a program called Cozy Room, and what's really fun is that basically it was like Zoom, Slack, and all those programs do not give us like a palette of emotions that is even like remotely close to what we can do as human beings. And so we created those very cute cursors where you have your mouse here, and when you move it, like the head follows, and by pressing a few keys on your keyboard, you can raise an eyebrow, or have your tongue come out, or open your eyes, or make them smaller. And so you can gradually you can create a layer where emotions are part of the, I'd say, collaborative process. And it's so much better than just having a voice channel in any of the SaaS software that we use every day. And there are also less well-known experiences, like John Underkoffler Mezzanine. John Underkoffler is well-known for being a consultant on very big movies like Hulk or Minority Report or Iron Man, where he basically invented the computer interfaces of the future for those movies. And he actually also created real programs with them. Mezzanine being one of them. And so it's working on so many great things. Like, for example, let's say we have a screen like that one. And I have my computer in my hands, and I just walk to the screen, and the computer is going to pass its context to the screen because the room has devices that allows the computer to talk to the other environment devices. And so you can do, like, you can send particles from one screen to another. You can extract just one slide and drag it over to the other computer, which is like really cool. And what you see here is that he has gloves. And so this is from a TED talk he did. If you have some time, like, just look at it, TED talk, and there is a grid of pictures. They are stacked, and you just like pull them apart. And that's absolutely fantastic, and that's what we should do. And there are things that are closer to us and maybe easier to do. Again, in that same vein of let's try to create an environment that is collaborative by default, much closer to what Figma does, for example. But here, what I think is absolutely fantastic is in Alexander Obenauer exploration, in this one called Breadboard, you have stickers or objects. Here, for example, you have a map. And on that map, you have asked the map to show you all the place where you could park an RV. So Campground Finder is going to tell you, like in Campground Finder, you say, I want to park my RV somewhere near, show me all the campgrounds. Then you bring up a map, and those objects will translate their context to one another. Then you can have the weather. And so this is the kind of environments that we should try to build. Like, we should also try to have interactivity at the object level. This was the goal of HyperCard, for example. In HyperCard, there is a very good interview in, I don't remember where, but from 1988 with Bill Atkinson, and he says, the problem of computing right now, and I think this is related to that fork in the road and those evolutions of microcomputing, apps have all the interactivity, and documents have all the data. And so apps can only be created by what he calls the priorists, which are the developers, and documents are created by the lemmings that we all are, the users. And it's like we need to find a way to make the document interactive itself so we can get rid of apps, and so we basically work in an environment where everything can be malleable, can be authored, and can be interactive. And so basically what I want to invite you to do, and I'd be very happy to discuss with all of you, is how can we foster experiences that are more like that, like people collaborating, sharing documents on, you know, in third places. And how can we also do that? Like, one thing that was, when I was doing that talk, I wanted to start with that Atari computer I mentioned in the first slide. That Atari computer had a forerunner called the Atari 800, which is the first computer introduced by Atari in 1979. And it has 4 controller ports. You could plug 4 joystick to play with people. And we never think about that again. Like, what is a co-op mode in a productivity software? Like, how do we split tasks? Can you go do some stuff in one corner and I do stuff in another corner, and maybe we do not have the same tools, but we converge towards an artifact together? How can we have asymmetrical gaming in productivity software? How can we really move past those very, I'd say, fixed, completely iced experience where we all have the same UI, we can open a voice channel, there is some data, but it's like super cold, you cannot add stuff from the exterior. How can we make that happen? And so this is how I want to end. This is a blank sheet of paper. I think we can all dream up great things while we are at Causal Island. And my personal favorite would be to arrive at a computer that would look like that. So come talk to me and we'll design it together. Thank you. It was a real pleasure. And if you have questions.
Amazing. Thank you so much, Paul. That's absolutely the kind of vision that I love having laid out for us all. Questions?
You saw me coming. Merci, Paul. That was fantastic. There's one word that you used twice that I think is actually fundamental to all this, other than collaborating and et cetera, because it is what contains all of that. And that word is context. We are terrible at contextual computing.
Yeah.
We are terrible at sharing context. And one of the reasons for that, I believe, is that it can be very personal, it can be very cultural, situational, and that's very difficult. I would love to see, I don't even know how to formulate this into a question. How do we do that? You know, based on all this history that you shared, which I'm thankful for the walkthrough and the reminder. I'm struck by how textual-minded computing technology is. You know, it came from this scientific mind of text everything.
Yeah.
What if it had come from a more physical perspective? We saw spatial computing. There's a lot more of that coming. How do we bring these two things together?
Yeah.
Context, the real world, as opposed to just lots of text on a screen.
That's a very good question. And there's an interview, so I'm sure you all know Ted Nelson, who wrote Computer Lib and Dream Machine, and who is the designer of Xanadu, which was a forerunner to the web. He's also the guy that coined the hypertext term. And he talks exactly about that. Like in a 1965 talk, he's like, how can we create a file system for the changing, the complex, and the indeterminate? And his solution is basically what I try to talk about when I mention HyperCard, which is we need basically an environment that would allow us to almost cut and paste tools so we can pass context to objects. And I have no real good answer, because what's super hard is it's easy to think about a solution in abstracto. Like, let's say there's no computers, we design one, we know about all the problems we have right now, we can solve them. Like, I think Folk, for example, has great solutions to give context, because you can do so much things with paper and you're not restricted to the tools you have on the screen. I think Lou and Orion also are doing wonderful explorations with SteelDraw that shows what's possible if you have a true malleable environment. And so I think the solution is right there. It's basically, I think we have to admit that we will not find a way to make the desktop itself, like the first environment of the computer, collaborative and contextual. So we basically have to admit that there will always be another layer, because we will not start an OS from scratch. And even when we do start an OS from scratch, like I'm sure you've all seen like Vision OS, which is like, it's a technical marvel. But like the OS itself, it's really funny, because at some point in the Vision Pro presentation, the guy opened Excel, and it's the same Excel. And I'm like, dude, you could have cells everywhere, you could do things amazingly. So we have to be compatible with what pre-exists now. I think that's obligated, because there's just too many people. Like I recently learned that there are 1.2 billion people using Word on Earth every day. And I'm like, that's 1.2 billion, that's too much. And so, but like it's not going to change. So I believe we need to find a way to add the contextual layer above, Yeah, or below, but below is going to be very expensive and hard. So I think it's really like there are some exploration by a guy named Rony in the US, where basically he invented a thing where your cursor can shapeshift and you can like snapshot everything on your screen and ask an agent to give context and to share that to other people. But that's still like that's a step. So no good answer, I'm sorry, except like let's rewind back to 1970. And
I think a message, and I really, really appreciate Paul doing this talk. He runs a Discord called HyperTalk, also founder of Kosmik and one of the main sponsors of Causal Islands. He was another one of the people who said, we have to have Causal Islands in Europe, right? So there are roots of Causal Islands in things like Strange Loop, which doesn't happen anymore. And part of that was to have it move around. And another thing that Paul said was, we can't have it just be one company. So in case that company goes away, like mine, Vision, which did the first one, that it keeps going. And the other thing is exactly this, and anyone who's interested in this, like some of this is, he's done an amazing job, like we'll make sure we get transcripts and a bunch of other things like this and build this for the community, because just this one talk has so much stuff to explore. So I also welcome everyone, right? The reason we do Causal Islands is that we have deep information and deep discipline is build a context layer, an interaction layer, a new operating system. So maybe we can start with a few hundred people and we'll work our way up to a million. Other questions?
Thanks. Thanks for the talk. So one more thing that comes to my mind when you talk about computing for everyone is peer-to-peer networking. And it's interesting. I discovered the old kind of peer-to-peer networking through an networking course, and realized that the recent, the notion about the decentralized computing is much more complicated than what it was before. And do you think peer-to-peer networking would come back again? And I think I personally believe it should, because it brings in the collaborative nature without the presence of cloud. Yeah, how does this?
So that's a very good question and a deeply personal one, because Kosmik and like Fission also, at Kosmik, when we started, we said, okay, we want to create a software that is spatial, but that is also local first, peer-to-peer, end-to-end encrypted. And the problem is that this is obviously the right way to do things, but it adds a level of complexity that for a startup, which comes back to that idea that you need to like basically have hundreds of people maybe dedicating less time but always contributing than one company. At Kosmik, what we did is we took IPFS, so a great peer-to-peer protocol, and on top of that we built a database that fit the bill that we needed, like transclusion, authorship tracking, versioning, a lot of stuff. And the problem is that, to go back to your question, we are VC backed, like a lot of startups, because that's the only way to basically say, we're going to be in a cave for 3 years, we're going to try to do something, and we'll see if the market wants it. And thankfully, part of the market wants what we build. And the very, I think, deeply rooted issue is that users, when you try to sell software, absolutely do not care about anything I said. We found some, I wouldn't say product market fit, that would be too cocky of me, but we found some responsiveness in creative agencies, with some technical firms, some people, like they love Kosmik and they use it. But when we tell them, hey, by the way, we do not even have your password, they're like, I don't really care. And so that's the problem. And that goes back to your question, which is like, the issue is how do we convey the idea that this is the best way ecologically, because it means you do not have data centers running everywhere. Technically, because it means that you run anything on your computer. And economically, like that was in our pitch to VCs, and it was true. We were like, we have no infrastructure, which means that as we scale, we do not do like bad things to the environment, and it does not cost us a penny. As more users use Kosmik, the network only gets better. So I think it will come back because it's obviously technically a very good way to do things. But the problem is, and I may be disillusionized by the last 3 years of building what I've built, it's almost impossible to build something that's production ready at the level of quality of apps like Notion, Figma, that are Marvel. Like when you use them, you can say, oh, Notion is slow, or Figma has problems. Yes, maybe. But fact remains, those are the almost only 2 companies that made a dent within the monopoly of companies like Adobe or Microsoft or Google in very big areas of the market. And they did that with Postgres, basically. And very advanced on, but or Firebase, but we don't really care. And so the issue is, how do we make sure that we find a way to come together to build a layer, peer-to-peer, for example, with encryption, with data protection, with everything, but that it's like maintained by so many people that a startup could adopt it without risking its own life. Because for us, for example, the call was very simple. At some point, our VCs came to us and they were like, you're spending the bulk of your engineering resources not on the canvas and the features that people would actually pay for, but on some conceptual thing where you tell people you do not have their password. And that's like, I have no good answer for them. So we just said, okay, we're going to not do that anymore and like sell SaaS software. And then we'll have a lab because we'll have profits. So yeah, I think it will come back, but it's a very hard problem.
Other questions?
If someone here has a lot of money, we can solve a lot of issues.
Yeah, I think that's another recurring theme. Phrases like protocols over platforms. The protocols have to come from somewhere. And again, this version where we have to decide to really compromise and decide to go, oh, I'm going to work with these 5 other companies and choose to push behind one thing, which also is a very hard fit, especially for an early stage startup. We talk about things like ecosystems and other things like that. I think one of the other themes, especially with some of the things that you talked about with housing, is I wonder how much tech has in common with things like a buy local movement, whether it's small business or a farmer's market. And in many ways, this is the same story, is we have lost a connection to the end user who doesn't really understand that software is made outside of Microsoft or Google, and that one might want to buy from this elegant Parisian gentleman versus someone else. Would that prompt any other questions?
I'm not sure that prompted this question, but the last thing he said is if anybody in this room has money, and it's not, the problem is not that there's nobody in this room that has that kind of money. The problem is that there are organizations and people out in the world who have that money. And they're not paying, well, just to keep it on current reality, socioeconomic, political reality, they're not paying taxes. And therefore there's no, government-funded innovation programs or scientific research, the kind of ARPA and DARPA and et cetera, where all the American information technology comes from. And so that's the meta question as well, like what's going on?
Yeah, so I tried to understand that at some point. And I think like, there is obviously the kind of surface level, like in France we have like, in France we have a thing with taxes. We love them. And so basically a lot of corporations, especially like Apple, like at some point we had a Ministry of Finance that was like, I'm going to make Apple pay. It did not work, not super well. So the issue is that yes, there is that problem, but how is that like, there is a book called The Entrepreneurial State, which basically touch upon that problem. And the book is basically like the amount of credits that the government would pour into like space program and like network is basically a function of the threats that are imposed onto that government. You are going to try to win the space race if there is a race. You are going to try and have an infrastructure that can withstand an atomic explosion if you really think that there is a world in which you can be hit by a nuclear attack. And there is another thing which I think is much more, much harder to understand. There is a book called Future Shock, written by Alvin Toffler, which you may know, futurologist, published in 1971. And I think there is another fork in the road, and the problem is that we never really took computing, and especially computing history, as a real field. Like, even if there are great institutions like the Computing History Museum and other, like, there are a lot of people doing great stuff, we do not talk about computing history beyond, like, oh, it's engineering. And there are political beings working in the tech world. Like, for example, in 1972, Lee Felsenstein, who was born to communist parents, put a computer in Berkeley called the communal memory, and he was like, computers should be basically everywhere. You should have kiosks where you could go and impute tasks and ask questions and put messages, and you should have like, there is a very much more, I think, intimate relationship to technology, which is, do we want to build devices that we find in the world? Like, for example, maybe we will find folk instances in any municipal library, or do we want to have devices at home? Do we want to have phones on our, like, what do we want? And I think, like, I did not find a better word than suburban computing, because it's really what it feels like. We have computers, but we are basically forced to use cars, like SaaS apps or abstractions, to basically function. Like, we have to copy and paste, we have to duplicate, we have to send emails. And I think at the root of that issue, there is a deep political conception about what is computing. And is computing, like, for profit for the people? Is there a middle way? There are so many things that we do not know and that we should know. When Apple introduced the Apple II, a company called Franklin cloned the Apple II. They cloned the ROM, because at that point in time, it was not clear that software could be patented or protected. In France, for example, you cannot put a patent on software. It's considered what we call a creation of the spirit, like a book or a movie, which is a completely different area of the law. And so the Franklin trial, for example, is a very interesting example, because the case that was made by the Franklin company was, computer software is like mathematical functions. They are not created, they are discovered. And code basically exists in that Platonic realm of ideas, and you discover it, you do not invent it, which I think is very salient now that we have agents. And thankfully or not, the trial concluded that yes, no, code is written, code is invented, and code can be protected, and that's yet again another fork in the road. And so this is, in my opinion, what we need to analyze and understand. We need to understand what happened politically, like how those movements got more individualistic, how the entrepreneurs themselves got shifted completely. Like Steve Jobs wanted to give computers to school, and now we have people, and I'm not criticizing the technical achievements, but we have people like Elon Musk that are extremely political, that wage immense power, and that definitely believes in that way of basically meritocracy trumps everything, even democracy. And so, again, this is a societal problem that is basically I think we need a center to study computing history and cross-reference it with every other field. So again, if someone has money, I take donations.
Thank you. Paul, thanks for the talk. You mentioned before how your users didn't care that like something was local first or encrypted or peer-to-peer. I think there's like two approaches to that. One is to then go, well, the market doesn't want this, so we'll do something else. The other one is to say, well, the market should want this for like, you know, some of the reasons that you've spoken about. It's better for the environment, it's better for the world, it's better for people's data, etc. I think there are sort of like two things you can do if you want to take that other path. One might be find an indirect effect. So maybe you can work offline in the train, maybe you can share stuff in a more easy way. Like, for example, a lot of users don't care that there's some like fast GPU in their computer, but you know, they want to have like 100 tabs open. The other way is like making people care. And I think there's actually a really good precedent for this. So I think a lot about, in terms of this, I thought about free-range eggs a lot. Because probably about 30 years ago, no one gave a shit like if their egg was from a paddock or not. You know, it was just like you have breakfast. There's been like a very successful, I'm not sure actually the entire history, but like there's clearly been a very successful effort to make people care about the condition of like chickens that does not directly affect them in any way. The eggs, maybe you could argue they taste better, maybe not. People probably don't notice. So I wonder what you think about those two approaches in terms of like changing a mindset through maybe some sort of public campaign, or finding those indirect effects, or how you could actually go down that second path.
I fully agree. Several problems though. When you work, and that's honestly I think something we can all learn from. When we said Kosmik was built on IPFS, when we said it's peer-to-peer, decentralized, encrypted, we also had to build something that you could download on an app store or log in through like a browser, and that comes with constraints. That means you cannot have the purest form of the implementation. And so some of the users that could have become ambassadors for us, that were in those communities about decentralization and security, and like honestly that also touches upon like civil liberties, like I want my data to be private, were our harshest critics, because they are like, you're not pure enough. And I was like, we are the only software on the market that you can download on the Mac that has that level of security. There's just nothing like that out there. And it's not enough. So basically the problem is that, again, you end up with the incentive problem, which is our community grew, and that group steadily grew. But the other group, what I would call the man on the street user, grew faster. And so we found out that the bulk of our resources in support were going to supporting users that were those harshest critics. And I was like, it basically, as a business, for us, it was bad business. And there are companies like Anytype, for example, very good company, well-funded, awesome product. They seem to have found a way. The only issue is that market expandable enough to reach product market fit and to them have a total addressable market that will put stars in the eyes of a VC when times come to raise a Series B or C? Because the other problem is that once you've put a finger in the VC ecosystem, you will play by those rules because you have a fiduciary duty to your investors to try to make them good money, to try and give them an exit, and to try and have that valuation go up, 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 up. And so we probably cornered ourselves at Kosmik, and I don't know personally, like I haven't found the solution, the balance that would have allowed us to develop a protocol that would have been open source. I think this was kind of the original mistake. We talked about that with Boris. We should have probably developed our protocol as a second product and put it in the open and focus on the canvas as our commercial venture. That's also very hard to do, but that would probably have helped us a lot. So I think it's really about, and to go back to the egg campaign, the problem is like you had those ads plastered everywhere. No startup in the world has that kind of power, except for example, like PARC from the browser company. They made people care about browsers, which is like honestly something great because nobody was thinking that the browser was a problem to be solved. And they just like, they run with it, they have a great marketing team, they tell awesome stories and they're like, you need a new browser for X, Y, and Z reason. And it seems like it's working. But I think they will also at some point have to contend with the fact that they have a lot of VC funding. They will have to become a paid product or find a way to make money. And if it's not paid, then what is it going to be? And how will they be able to stick to their original values? So again, I think like at some point for me, at least at my personal level right now, I haven't found a way to mix the two and to effectively push those ideals with the accelerant that is VC funding, because that was my hope, that VC funding would allow us to solve all of those very deep problems. Like we spent 1 year making working on IPFS to make it run on the iPad and on the iPhone to have a real like cross-compiled protocol. And then another year to add a multiplayer mode with a branching mechanism with like another encryption layer. We went kind of overboard, and so and we were allowed to do that because of the VC funding. But at the same point, that VC funding basically was not getting the return from the market. So that's something to think about. I think there's a solution. We unfortunately haven't found it yet.
I think there's something there definitely around the sort of, I'll say, P2P maximalist. I know in general that entire market, and there has been some people who say messaging, oh, you have a server? Or you have a bootstrap server? Or you have something that works online? Not peer-to-peer enough. Can we not, in the future, perhaps, but pragmatism is hard, I think, in this space.
I think just to add something, one company that did something recently that could be interesting, I know they are very polarizing, but the Basecamp people, they came up with something called wands.com. So go on the website, it's very interesting, where basically they say, either you want something that's prepackaged, like let's say processed food, and you just want to warm it up in the microwave, that's the SaaS software. Go on our website, subscribe, pay a monthly subscription, it will always work. Or you are much more technical. You know your way around the server, around some protocols, around the computer basically, and you buy a license for one version of our code right now, plus one update. But you deploy it, you maintain it. And I think this is a very interesting approach, one we're exploring at Kosmik too, to hopefully one day have a fully peer-to-peer decentralized product on the market, where basically we're like, you are a user, you have a MacBook, you want to go on the App Store, you can download the app, you're good to go, you can log in with SSO, link your Google account, that's great. Or you are an organization. For example, at some point we worked with a studio that had to manage a lot of IP related to famous movies, and they were like, we're interested in Kosmik because you have a level of security we haven't found in other SaaS products. They would probably have bought that because they had an IT department. So it's a small market, but that could be a great solution to just like hinge closer and to show that it can work in production. Because the proof is in the pudding also. Thank you very much. Thank you all.